Okay, so we're going to test a claim using what we're going to call a p-value test. And the p-value test is going to be able to be used for both left tail, right tail, and you can use it for two-tailed tests. Okay, so the p-value is expressly is what is the probability that the null hypothesis is true. And we're going to compare that p-value against alpha. So recall that alpha, if I take 1 minus alpha, I get the confidence level. Okay, so we've been taking a 95% confidence level for most things, which means that we're going to use pretty much alpha as 0.05. And what we want is we want the probability that, so if the probability of the null being true is less than 0.05 or alpha, then we're going to reject the null, because this says that there's a small probability that the null hypothesis is true. So we're going to reject it. If the probability is equal to or above alpha, then we're going to fail to reject. Okay, so if the p is small, then we reject the null. Otherwise, we fail to reject it. All right, so let's take a look at a possible claim and see if we can't make something work here. Okay, so our claim is going to be that less than 45% of the class is happy with the venue chosen for the dance. Okay, so how do we test this claim? All right, so our null hypothesis here is that the proportion of the class that is happy with the venue is 45%. The alternate hypothesis is that the proportion that's happy with the venue is less than 45%. So note here, my alternate hypothesis represents the claim. Okay, this is left-tailed. This is a left-tailed test. So if there's error, it's going to be to the left-hand side. If there's error, let's just say that this is a left-tailed test. Okay, so we're going to test this claim. We're going to take a sample of 40 members of the class chosen at random, and we find that 15 of them are happy. They're thrilled about the venue, which means that, a considerable number aren't exactly thrilled about it. All right, so what we're going to do is we're going to use the calculator to kind of conduct this p-value test. Okay, so where I find this on the calculator is I go to stat and I go to tests and I go down to 1 proportion z test. So instead of the 1 proportion c interval, I'm actually going to do the 1 proportion z test here. And I'm testing, well, my claim is that the proportion is 45%. That's the claim I'm testing against. I took a sample of 40 people and found that 15 were happy with it. Okay? My alternate hypothesis is a less than statement, right? So what I do is I highlight that, indicating that I have a left-tailed test. Okay? Now, what I do here is I come down and I calculate, and there's my result. The key number here is not the p hat, but the p. That p value is 0.17. Okay, now that may seem like that's a small number, but it's not below 5%. So that 0.17 says that the p is greater than alpha. Okay, so let's go back and take a look at what that means. Okay, so since p, which is 0.17, is greater than alpha, which is 0.05, we fail to reject the null hypothesis. Okay, because yes, there's a 17% chance that the null hypothesis is true, but we can't rule it out. like if it was less than 5%, we would rule out the null. So it is possible that 45% or more of the population actually likes the venue. So it's not necessarily true that we cannot say that we know statistically significantly that the portion of the population that doesn't want the venue is below 45%. So in the end of the day, we fail to reject the null hypothesis, but the claim is the alternate. So remember, when you're doing a left-tailed test, if you fail to reject the null hypothesis, you are actually rejecting, or we're not rejecting, but we're saying that the data, in plain English, does not support the claim. All right, so that is a p-value test for a left-tailed situation. Let's take a look at one where it does two-tailed. Okay, so let's do that. Okay, so let's say in our two-tailed test, 80% of consumers prefer product A over product B. So my null hypothesis is that the proportion of the population that prefers product A is 80%. Okay, so 0.08. The alternate hypothesis here is that that's not true, so that it's not 80%. Okay, so this is a two-tailed test. All right, so let's take a sample. Let's say we take a sample of 250 consumers and we find that 180 actually preferred A over B. Okay, so at this point, I have everything I need to feed this test into the calculator. All right, so we're going to pull the p-test again. So we're going to go to tests. We're going to go down to one proportion z-test. And we're going to say we're testing against 80%. In our story, we had a sample of 250, and of those, 180 said they prefer type A, and we're doing this as a two-tailed test, so we use the not equal to, and we calculate this, and our p-value here is 0.001. So that means the probability that the null hypothesis is true is about 1/10 of 1%. Well, that's definitely less than 0.05. Okay, so let's take a look at this from the point of view of the test. Okay, so we got that P was 0.001. I mean, at best, it was 0.002, which is significantly less than our significance level of alpha at 0.05. So what does this tell me? This tells me that since P is smaller than alpha, we reject the null hypothesis. Now remember, in a two-tailed test, the null hypothesis is the claim. So again, the data here does not support the claim. The claim here was that 80% of the people prefer brand A to brand B or product A to product B. We do not have sufficient evidence to support that claim. So there's a couple of examples of using a p-value test with a proportion to test a claim. All right, there you go.